Okay, we're going to look at properties of the scalar product. So these are some things that are definitely true. Okay, the first of which being that A dot B is equal to B dot A. Okay, so that can be easily shown if I've got a vector A which is 2, 1, 3 and a vector B which is 1, 5, 2. Well, it follows that if I do that times that plus that times that plus that times that, I'll get the same result if I do it backwards, that times that plus that times that plus that times that, which shows that that's true. Okay, another result that's true is that A dot B plus C is equal to A dot B plus A dot C. So I'm just going to prove that's true just now with an example. Let's say the vector A was 1, 2, 3. Vector B was 2, 3, 2, and vector C is 1, 3, 2. Okay, so A dot B, well, that would be 1 times 2 is 2, plus 2 times 3 is 6, plus 3 times 2 is 6. And then A dot C would be 1 times 1 is 1, plus 2 times 3 is 6, plus 3 times 2 is 6. Okay, put them all together. 2 plus 6 is 8, 14, 15, and that will be 27. Okay, what I'm going to do now is find a vector B plus C by adding B and C. So that's 2, 3, 2. Plus 1, 3, 2, which is equal to 3, 6, 4. So that's the vector B plus C. Okay, so if I now do A dot the vector B plus C, well, that's going to be 1 times 3, which is 3, plus 2 times 6, which is 12, plus 3 times 4, which is 12, and you can see that that gives me the same result of 27. So that result must be true. A dot B plus C equals A dot B plus A dot C. Okay, so that's two ones that we should be remembering. Okay, that will not be given to you in the formula sheet. Okay, so an extension of this result would be that A dot A plus B plus C then would be equal to A dot A plus A dot B plus A dot C. Okay, let's try some examples then. So let's go for this one. Okay, we're going to calculate P dot R plus Q. P is equal to 3, or rather the magnitude of P is equal to 3, the magnitude of R is equal to 3, and the magnitude of Q is equal to 4, and they sit on this diagram. Okay, so P, R and Q, and we've got angles in here of 30 degrees and 30 degrees. Okay, so that's P dot R plus P dot Q. Okay, so let's take each one in hand. So P dot R is magnitude P, magnitude R, cos theta. Okay, so magnitude P is 3 multiplied by magnitude R, which is also 3 multiplied by cos theta. So what's the angle in between P and R? Well, we can see it's 30 degrees, so that's cos 30. Cos 30 is an exact value, which is root 3 over 2. So that's 9 times root 3 over 2, which I can write as 9 root 3 over 2. Okay, let's now go after P dot Q. Magnitude P, magnitude Q, cos theta. Magnitude P is 3, magnitude Q is 4, 3 times 4 times cos theta. What's the angle in between P and Q? Well, we can see it's that 30 plus that other 30, so that's actually cos 60. cos 60 being 1/2, so that will give me 6. So the final answer then is going to be 9√3/2 plus 6. Well, I can write that as 9√3/2 plus 12/2, which is 9√3 plus 12/2. Okay, example 2. Example 2, I've got parallel vectors B and C are inclined at 60 degrees to vector A. Okay, so there's a diagram for that one, which is as follows. Okay, so that's a dotted line just to show what would happen if that was extended on. 60 degrees, magnitude of that vector is 2, that one's 4, and that one is 3. Okay, now the question is, can we find A dot A plus B plus C? Well, that's A dot A plus A dot B plus A dot C. Okay, so magnitude of the scalar product A dot A, that's magnitude A times cos theta. Okay, so the magnitude of A then is 3, so that's 3 times cos of, what's the angle in between? Well, if you think about the vector A and then place the vector A on top of it, the angle is 0. So cos of 0 is 1, and that's 3 times 1, which is 9. Okay, A dot B, magnitude A, magnitude B cos theta. Okay, so vector A, right, so let's get a magnitude of 3 multiplied by vector 2, vector magnitude of 2 multiplied by cos theta. Well, we can see that the angle in between is 60 degrees, cos 60. So that's 6 times cos 60, which is 1/2, and that's equal to 3. Okay, now I'm going to try A dot C. Well, A dot C is magnitude A, magnitude C cos theta. So the magnitude of A is 3, magnitude of C, as we can see, is 4 multiplied by cos theta. Okay, so let's have a look at that. So there's the vector C and the vector A. Now we could be tempted to say that that's the angle there, but we need vectors pointing away from the vertex. This one is, but this one is pointing in, so what we need to do is move that vector, this vector, over here and place it here. And then vectors are pointing away from the vertex. The angle is 60 degrees, cos 60. So that's then 12 times cos 60, which is 1/2, and that's equal to 6. Final answer then, let's put them together. 9 plus 3 plus 6, and that is 18. Okay, example 3. Example 3, vectors A and B. Make an angle of pi/6 radians. Magnitude A is 3, magnitude B is 4. And we're going to show that A dot A plus B is equal to 9 plus 6√3. Okay, we've got a diagram here. So there's the vector A, there's the vector B, and the angle in between is pi/6. Okay, so it's going to be A dot A plus A dot B A dot A is equal to magnitude A times magnitude A. Now we could go through the routine of saying cos of 0 again, but I think we just stick with then knowing that A dot A is equal to magnitude A times magnitude A, which can then be written as the magnitude A squared. And we can generalise that. If I was looking for D dot D, that would be the magnitude of D squared. Okay, so that's going to be 3 times 3, which is 9. Let's now go after A dot B. A dot B is going to be equal to magnitude A magnitude B cos theta. Okay, so magnitude A is 3, magnitude 4, B is 4, cos pi over 6. Remember that pi over 6 is 30 degrees, so that's 12 times cos 30. Cos 30 is root 3 over 2, so that's 12 times root 3 over 2, which is 12 divided by 2 is 6, 6 root 3. Bring it back in then, 9 plus 6 root 3, final answer. Okay, let's try another. We've got an equilateral triangle, which is denoted by those 3 lines there. I'm going to say that that is vector P, that's vector R, and that is vector Q. Okay. Now we're going to evaluate 2 things here, Q dot Q plus R and P dot Q plus R. What I'm also going to say is that the length of each side is 3 units. Okay. So let's go after Q dot Q plus R. So it's Q dot Q plus Q dot R. Okay, so Q dot Q is magnitude Q squared. So that's just 3 squared, and that's 9. Q dot R, that's magnitude Q, magnitude R cos theta. Theta is the angle in between Q and R. 3 times 3 times cos of theta. Okay, so what's the angle in between Q and R? Okay, well, that's 60, 60 and 60, since this is an equilateral triangle. There's R, there's Q. It could be tempted to say 60 degrees, but remember that the angle needs to point away from the vertex, so I need to lift this vector Q over to here, so that the vectors are pointing away from the angle. Now that means that that angle then will be 120 degrees, since that is a straight line. Okay, so it's going to be cos 120. So that's 9 times cos 120. Cos 120. Okay, so let's do that one. This is now harking back to some trig work. Okay, 120 degrees is in the sine quadrant, cos is negative in there. The acute angle is 60 degrees, and that is minus 1/2. Okay, so it's 9 times minus 1/2 minus 9 over 2. Okay, so the final answer then is going to be 9 plus 9 over 2, or minus 9 over 2 rather. So that's 18 over 2 minus 9 over 2, which is 9 over 2, final answer. Okay, let's go for P dot Q plus R, so that's P dot Q plus P dot R. Okay, so P dot Q, magnitude P, magnitude Q cos theta. 3 times 3, okay, P and Q, they're both pointing away 60 degrees times cos 60. That's 9 times 1/2, and that is 9 over 2. Let's now go after P dot R. So let's do that. P dot R, magnitude P, magnitude R cos theta. Okay, so that's 3 times the angle in between P and R. Okay, so as you can see, they're not pointing away, they're actually pointing into the vertex. So what I'm going to do is just bring that bit of that diagram down here and see how we would deal with it. Okay. So remember that I need, when I'm doing the scalar product, I need that the vectors will point away from the vertex. Okay. So How do we do that then? Well, we're going to take the vector p and move it up here. And then we're going to take the vector r and move it up here. They're now pointing away. They're opposite angles, so it's still 60 degrees. Cos of 60, that's 9 times 1/2, which is 9 over 2. Put them together then, 9 over 2 plus 9 over 2 will give me a final answer of 9. Okay, let's try one more. Okay, there's a vector b and a vector a. The angle in here is 45 degrees. And I'm going to say that magnitude A equals magnitude B equals root 2. Okay, so we're going to find A dot A plus B. So that's A dot A plus A dot B. Okay, A dot A equals magnitude A squared. So that's root 2 squared, which is 2. Let's now go after A dot B. Magnitude A times magnitude B times cos theta. That's root 2 times root 2 times cos. Okay, let's think about the angle. So again, I don't have a situation in which the vectors point away from the vertex. One does, one doesn't. One points in and one points away. So what I need to do then is move the vector B down here so that they're now both pointing away, but it creates a new angle, 135 degrees. So at that point, I then go to the side, cos 135, cast diagram. Okay, I'm going to be in the sine quadrant, cos is negative in the sine quadrant, and my acute angle is 45 degrees, and that is minus 1 over root 2. So that's root 2 times minus 1 over root 2. That's 2 times minus 1 over root 2. And that's minus 2 over root 2. And then I'm going to rationalise that denominator. And that will give me minus 2 root 2 over 2, which is minus root 2. Okay, let's bring it all in then. So it's going to be 2 minus root 2, final answer.